Space is full of strange worlds. Frozen moons drifting through darkness, gas giants wrapped in endless storms, dust-covered planets that have not changed for billions of years. But one planet stands apart, a world so hostile that even our strongest machines struggle to survive there for long. That world is Venus. From Earth, Venus appears calm. It shines brighter than any star in our night sky. For centuries, people imagined clouds hiding oceans beneath the surface. Some even believed Venus might be another Earth. But the truth is far more extreme. Venus is not a paradise. It is a planetary furnace. And today, humanity attempts something that has never been done before: a human descent to the surface of the most hostile planet in the solar system. The spacecraft slows as Venus grows larger in the viewing window. From orbit, the planet looks almost familiar. Venus is nearly the same size as Earth. Its gravity is similar. At first glance, it could almost be our twin. But beneath those thick yellow clouds lies an environment unlike anything on Earth. The atmosphere of Venus is 90 times denser than ours. Standing on its surface would feel like being nearly 1 kilometer underwater. And the heat is beyond anything humans normally experience. Surface temperatures reach 465 degrees Celsius, hot enough to melt lead, hot enough to destroy most electronics within minutes. The descent capsule separates from the main spacecraft. Small thrusters fire briefly, then gravity begins pulling it downward, slowly at first, then faster. As the capsule approaches the upper atmosphere, the air begins to glow. Friction ignites the gases surrounding the craft. The capsule becomes a falling meteor. But atmospheric entry is only the beginning, because the real danger lies deeper. At 60 kilometers above the surface, the capsule enters the cloud layer. Visibility disappears instantly. These clouds are not made of water. They are made of sulfuric acid. Tiny droplets of acid suspended throughout the atmosphere. Anything exposed to them begins to corrode almost immediately. Outside the capsule, lightning flashes through the thick clouds. The storms of Venus are powerful, but because the air is so dense, thunder behaves differently here. Instead of sharp cracks, the sound rolls slowly through the atmosphere, deep, heavy, almost like distant explosions underwater. As the capsule continues falling, the pressure outside rises rapidly. 10 times the pressure of Earth, 20 times, 40. The spacecraft's hull begins to feel the weight of the atmosphere. The deeper it descends, the thicker the air becomes. On Venus, the atmosphere is so dense it behaves almost like a liquid. Moving through it feels less like flying and more like sinking. After nearly an hour of descent, the clouds finally begin to thin. For the first time, the surface becomes visible. The landscape below is dark and volcanic. Endless plains of hardened lava, jagged rock formations stretching to the horizon. And above it all, a dim orange sky. Sunlight struggles to reach the surface. Even during the day, Venus looks like a world trapped in permanent twilight. The capsule touches down. The landing is heavy. Outside pressure now reaches 90 atmospheres. The weight of the atmosphere presses against every surface of the spacecraft. Inside the capsule, systems work constantly to keep conditions stable. Cooling systems circulate fluid through the equipment. Thermal shields absorb the relentless heat, because outside the capsule, no human could survive for more than a moment. The astronaut prepares to step outside. This is not a normal spacesuit. It is more like a walking submarine. Layers of ceramic insulation protect against extreme heat. Reinforced joints resist crushing pressure. A powerful cooling system pumps chilled fluid through the suit. Without it, the astronaut would overheat in minutes. The hatch opens slowly. Thick orange air floods the camera. And for the first time in human history, a person steps onto the surface of Venus. Movement is slow, not because of gravity, but because the atmosphere itself resists motion. The air here is so thick that walking feels like pushing through water. Every step requires effort. Every movement feels heavy. The suit's sensors immediately begin reporting extreme conditions. Outside temperature, 465 degrees Celsius, the hottest surface of any planet in the solar system. Even Mercury, which sits closer to the Sun, is cooler than Venus. Because Mercury has almost no atmosphere, heat escapes into space. But Venus is different. Its thick atmosphere traps heat like a giant blanket. Carbon dioxide fills the sky. Sunlight enters easily, but the heat cannot escape. This runaway greenhouse effect turned Venus into a permanent pressure cooker billions of years ago. Scientists believe Venus may once have had oceans, water covering large portions of the surface. But as the planet warmed, those oceans began to evaporate. Water vapor entered the atmosphere, which trapped more heat, which caused more evaporation, until eventually, the oceans disappeared completely, leaving behind the scorching world we see today. The astronaut moves toward a nearby ridge. Sensors begin detecting unusual mineral deposits. The peaks of Venusian mountains behave differently than those on Earth. On Venus, it may actually snow metal. Lead and bismuth vaporize in the intense heat of the lower atmosphere. Higher up, where temperatures are slightly cooler, they condense again, falling like metallic frost onto the mountains. A strange phenomenon that exists nowhere else in the solar system. In the distance, a massive volcanic mountain rises through the haze. This is Mont Mons, one of the largest volcanoes known on Venus. In fact, the planet contains more than 1,600 major volcanoes. Many scientists believe some of them may still be active today. Venus is not just hot, it is geologically alive. The ground occasionally vibrates beneath the astronaut's boots. Deep movements inside the planet's crust, a reminder that this world is still changing. Suddenly, warning alarms activate inside the suit. Outer protective layers are beginning to degrade. Acid particles in the atmosphere slowly attack exposed materials. The cooling system struggles to keep internal temperatures stable. History provides a clear warning. The Soviet Venera probes were the only machines ever to reach the surface of Venus. Even they survived for less than 2 hours. Eventually, the heat and pressure destroyed them. Human technology has improved, but Venus remains one of the most hostile environments ever encountered. The astronaut returns to the capsule. Movement becomes urgent, but urgency is difficult here. The thick atmosphere pushes against every step. The hatch closes, engines ignite. Leaving Venus is one of the hardest ascents in the solar system. The spacecraft must fight against the weight of the entire atmosphere. Slowly, the capsule climbs upward. Pressure begins to fall. The clouds thin. The orange sky fades. And finally, black space returns. From orbit, Venus once again looks calm, a smooth golden sphere floating quietly in space, beautiful from a distance, deadly up close. Exploring Venus teaches us something important, not just about another planet, but about our own. Because Earth and Venus may have started very similarly, yet one became a home for life, and the other became a furnace. A reminder that planetary climates can change dramatically, and once they do, there may be no turning back. Venus remains a warning written across an entire world, and a reminder of how rare and fragile our own planet truly is.